Hello everyone, this is Mateus from Mining Math, and in today's video I'm going to explain a little bit more on the vertical rate of advancement, okay? Vertical rate of advancement. We have more about this, more formal explanation on this concept on this parameter in our knowledge base, and please let me know if you have any further questions about it. But the idea here is to show you a strategy you can take advantage of when you feel this parameter is being disrespected by SimSched. Of course, getting a little bit into the context on how SimSched works, we have many constraints being handled simultaneously. And basically, when your scenario is too much constrained, you might find a solution that you feel it's not satisfactory for your purposes. And well, this is because the scenario is too much constrained and the nature of your deposit, and SimSched is simply not finding a solution for it. So SimSched will start to do the work of relaxing some of the constraints according to a hierarchy that is also explained in our knowledge base. And well, this is pretty much the same work we do as mine engineers, as mine planners. We start with sometimes with the most constrained scenario where we would have the ideal solution, and then we realize that's not good as we expected, and then we start to relax some constraints that are not a priority for us, and in order to obtain a better result in terms of economic performance, of environmental performance, or whatever you're seeking in this moment. And well, the idea is that according to the hierarchy of constraints of SimSched, the vertical rate of advancement, besides its complexity, because sometimes the algorithm might consider some plateaus wouldn't be connected, but they are physically a little bit connected. Besides all this complexity of handling operational parameters such as SimSched has, there are some opportunities you can take advantage of to add further control to this parameter if you feel it's too much important. Okay, so the first thing to consider is that, well, if this is disrespected, so situation 0 would be if vertical rate is disrespected, you could start with 1. Relax some constraint. We have more explanations on this in our knowledge base. For example, if you have bigger area in terms of minimum bottom widths, mining widths, you could reduce these parameters in order to have a less operational geometry, and or not exactly less operational, but that wouldn't be the ideal, but would facilitate, for example, the vertical rates to be respected. Sometimes it might happen. And well, another example, you could observe the previous results you're finding, and you might realize, for example, the blending constraints are bottlenecking the whole system, and because of them, SimSched is trying to get deeper and consequently disrespecting the parameter you're using. But if you have already tried option 1 of relaxing some constraints to understand if the vertical rate is being respected or not, you could move to the second point, which is an additional control. So additional control over the vertical rate. So, and how you can do that? Basically, you will need to use the concept of surfaces, okay? More specifically, the restricted mine surfaces, okay? So the idea here is to, let's imagine here's your block model, okay, in a side view of it. Okay, so here is your block model and a side view. Okay, the idea is that, well, let's suppose a very hypothetical situation where you want to advance 10 benches per year, okay, and your blocks are 10 by 10 by 10 meters, and well, and let's imagine that this position is, okay, let's imagine this position is here. And well, for this period, your previous scenario is getting something like this, and you were disrespecting the overall vertical rate, and you're surpassing this mark of 100 meters, right? 100 meters depth, okay? 100 meters deep, actually. So the idea here is that you will create a surface, okay, a restricted mining surface. It can be even a flat surface where you are positioning this flat surface 100 meters deep. So if your previous scenario was getting this, it will get something like this, okay? It actually won't surpass this region anymore. So you will simply remove, SimSched will be forbidden to mine anything into the specified period, okay? So, and you can check the videos about surfaces to understand a little bit more about this concept on how surface constraint work on SimSched. But the idea is quite simple. So you have the topography over here. Let's say it's 1,000 meters of elevation, and then you want to restrict. You are having for the first period, the first year, you are having more than 10 benches, and what you need to do is simply to not allow, to impose SimSched to respect this maximum limit of mining for the first year. So you say from year 1 to year 1 in this case, I want to use this restricted mining, so SimSched won't surpass this maximum limit of mining. Okay, so that's the strategy you can use to provide additional control over the vertical rate of advancement on SimSched. I don't know how the solutions will look like. It might be better or worse. And then if you got a worse solution, you should try a little bit more on the relaxing some constraints. Okay, so that's all for now. If you have any questions, just a quick and brief overview on these sort of strategies. If you have any further questions, please contact support@miningmath.com. Thank you and bye.